Sometimes when you see a formula like the law of sines, it seems like it just fell out of the sky fully formed. Poof, here it is. And that is not how math works. So this is just to let you know where the law of sines comes from. The idea of the law of sines is I want to have a means of solving non-right triangles. We know lots of things about right triangles, trig functions, Pythagorean theorem, all that stuff. But if we have an oblique triangle, one that doesn't have a right angle, what do we do with those? So here I have an oblique triangle. First thing I'm going to do to it is I'm going to draw in its height. So the height goes from the highest angle up there perpendicular to the side below, and I'm going to name it H. And you might notice that by doing that, now I have two right triangles, one to the left and one to the right, which is good because we know a lot about right triangles. So looking at the one on the left first, I'm going to find the sine of angle A. Well, the sine of angle A is its opposite side, which is the thing we just drew in there labeled H, divided by its hypotenuse, which is C. Okay, that's nice. I'm going to take, that's a little equation now, I'm going to take it and solve it for H. So H is little c, side C, times the sine of angle A. Now I'm going to do the same thing with the triangle on the right. The sine of angle C now is its opposite side, which is also H, divided by its hypotenuse, which is A. I'm going to solve that one for H, and I get A times the sine of angle C. Well, if these two expressions are both equal to H, they must also be equal to each other. So I can say A times the sine of C is equal to C times the sine of angle A. Now I'm going to divide both sides of my little equation by both little a and little c. And as I do that, now I have sine of C over side C equals the sine of A over side A. If I had picked a different direction to draw the height in, I could have used angle B and C or angle A and B and ended up with this same ratio. So in the end, the law of sines says in any oblique triangle, any triangle, sine of A over A equals sine of B over B equals sine of C, not that, forgot the N, over C, and typically we use whichever two are convenient, but that's our statement of the law of sines.